Hello, Luke. Welcome to lesson 105. Today we'll be talking about factoring by grouping, which is pretty much exactly the way it sounds. So it should be a pretty short lesson today and hopefully quite straightforward here. And in a way, it's kind of fun, I think. It's not very complicated. It's using all the tools that we've already learned, and we're just kind of working on these problems that are, in all honesty, pretty contrived to make them work out in the end. So it's not very complicated. So let's get started. Factoring by grouping. What they'll do is they'll give you an expression such as this, and they will say factor by grouping. Ta-da! Factor by grouping. Okay, so what does that mean when they tell us that? Well, first off, you might just make a couple observations here. Looking at this expression, you might recognize that, yes, we have 4 terms in this expression, and that none of them are like terms, which means we can't do any combining here. We can't do any addition. There's nothing that we can do. In most situations, you would look at this and go, yeah, I'm done. There's nothing else I can do. There aren't any common factors that are common to all 4 expression or all 4 terms, and there aren't any like terms, so I can't add anything. So I'm done, right? Well, actually now there is something that we can do, and this is it, factor by grouping. So what you need to do is look at this and see if there are any terms that do share some factors. All right, so we don't need to look at all the terms. Let's just look at some of them and point out some terms that share a common factor. What do you see? Do you see any like that? Well, if you look at it closely, and maybe you saw this, you might say, okay, here's my first term. It has an x, y, and an a. My second term has a 4 and an a. So bingo, they do share one factor. They share an a, right? Now, the other 2 terms do not have a's in them. They don't have a 4 in them. And they don't have, well, this one I guess you could say has an x in it and a y in it, but this one doesn't. So if I'm just looking at these first 2 terms, I could, recognize that they do share an a. All right, there's an a that's common. Now, if I look at the second set of terms here, I might recognize that, oh, looky here, a b is common between these 2. All right. Now, understandably, so far, all we're doing is just making observations. We might also make an observation that, this one has an x and this one has an x. This one has a y, this one has a y. Yeah, we could look at those too. But maybe I'll just forewarn you, in most of these problems, they will set it up so that the first 2 terms will have something that's common, and the second 2 terms will have something that's common. And if that's what you see, then I would start with that. So, and this will make more sense in a minute. So as we're looking at these first 2 terms, recognizing that they share an a, let's factor out that a. So what we're going to do is essentially ignore the rest of this problem. We're going to just kind of divide this problem up into 2 pieces here. We're going to ignore this right-hand side, this blue side, and we're just going to focus on the orange side here. Okay? So if we look at our orange side, we could say, yeah, they share an a. Let's factor that out. So we'll set the a out here. Remember, we're kind of doing the reverse of the distributive property here. We're pulling out the a. That's going to leave us with an xy for the first term. In the second term, we're left with just the minus 4, right? All we did was factor out an a. We should be very familiar with that at this point. And there you go. So we factored that out. Now let's go to the blue side and factor out this common b that we noted before. So if we factor out the common b, we're left with an xy in that first term and a negative 4 in the second term. And this is where, and by the way, we have a plus sign right here. We don't want to lose him. There's this plus sign that we have to bring down. Okay. Now, this is where it becomes very obvious that this is a connived or a contrived problem. Okay. Because look at what we're seeing here. And I'm going to erase this bar, or at least part of it anyway. We'll erase it up to about here. Okay. And if we look at what's left, do you see a common factor? Now looking at both of these terms. what do you see? Well, lo and behold, this set of parentheses and this set of parentheses are the same, aren't they? Right? They're both x times y minus 4. Wow, that's amazing. How did that happen? Well, it was contrived to happen that way. In real life, this doesn't happen very often. But here, it did. So, since it did, we can now do one more factor. Just like we factored the a out of these first two terms, and then we factored the b out of these second two terms, now we can say, well, look at this. The part that's common is the xy minus 4 in these two terms, because, again, they are connected with a plus sign. I don't want to lose that. I want to make sure you see that there is this plus sign here. They're not being multiplied by each other. So the two factors for these two terms is the parentheses. So we can pull that out. So let's pull out the parentheses, factor out the parentheses, the xy minus 4, and what does that leave us with? So if we're pulling out this x minus 4, that leaves us with just an a. So we have an a, and then we have the plus sign, and then we're pulling out this xy minus 4 in the second term. That's going to leave us with just a b, and bingo! There we go. We now have factored it one step further. All right, so that is our solution. Now you might ask, why is this solution better than the original solution? Well, I'm not sure. In all honesty, it may or may not be better. Sometimes you may find that it's better to have it in this first form, with a bunch of terms that are being added together. In other times, you might find that it's better to have it in this form, where we have it factored, where we have it as a set of terms being multiplied by each other. It just kind of depends on the situation. But the goal right now is for you to be able to transition between those two. We know how to multiply these out using our FOIL. Well, if we have something nasty like this up here, how can we get it to this over here? And the answer is sometimes, not all the time. Sometimes we can do it by factoring by grouping. And that's where we group them up into, pairs of terms, or even, several terms together. And then we can factor out the common factor within those terms. All right. And then sometimes, lo and behold, we find that, oh my goodness, look at this. We have a common factor in the parentheses that we could then pull out a second time. All right, so let's try another one here. Why don't you pause the video, give this one your best shot, and then we'll do it again together. All right, so when they say factor by grouping, the first step is actually to group it. Okay, and I will tell you right off the bat that in this book, generally you won't have to rearrange this much. The best way to do it is just to kind of throw the first term in with the second term, group those two together, and then group the third term with the fourth term. Generally, they're going to be pretty nice to you, and that'll be the way that it'll work out. So I would just recommend starting with that. I know it's a little arbitrary because I could rewrite this expression in any order that I chose. It's not going to change the value. But I believe anyway in the textbook they're pretty kind to you, and they put it in the order that'll be the easiest to solve it. All right, so anyway, so group it up into the first and second term, third and fourth term, and then we're going to look for what's common in those parentheses. So what's common in the first term, or first set of terms, I should say? Well, the a is, right? The a is common in both terms. Is there anything else that's common? No, just the a. So we're going to pull that a out, we're going to factor it out, and we'll be left with the c plus 2d, right? There we go. We're done with the first one. Now let's go to the next one. This set of parentheses, what's common here? Maybe I'll change color. Well, actually, there's several things common here, right? Can you see them? What are the several things that are common? Well, one of them, maybe the more obvious one, is the b, right? The b is common for both terms. What else is common? Well, remember that this 4 can be written as 2 times 2. And that would mean that this 2 is common as well. There's a 2 that's also common, right? Think of it as I could reduce out a 2, factor out a 2. So I can pull out from this a 2 as well as a b. And if I pull that out, what am I left with? If I pull it out, I'm left with the 2 and the b disappear. I'm left with the c. 4 divided by 2 is 2, like we said. We're getting this one. And then we're left with not the b, but the d. All right? And then once again, look at the magic that happens. You just have to appreciate the magic that occurs here. And just, I suppose, just recognize that this does not happen in real life. In reality, when you're really working with mathematics, it's going to be pretty rare that you have things work out so incredibly nicely as they do in these problems. But hey, enjoy it while it lasts. These problems are made just for you. All right? So looking at it, what do we have that's common? Well, again, it's the parentheses, right? If you didn't already see that, that's the beauty right here. This is the magic. C plus 2D and C plus 2D. They are exactly the same. So I can now factor out the C plus 2D, just like I factored the A and I factored the 2B. So if I factor out the C plus 2D, what am I left with? Well, I'm left with, for the first term, I'm left with an A. In the second term, I'm left with a 2B. And there we go. Now it's completely factored. This is my factored solution to this problem. Excellent. So hopefully this makes sense. It is pretty straightforward. And again, these problems are contrived to make it pretty easy for you. But that's as far as we need to really go today. So go ahead and continue on in your seat work. Good luck, and I will see you tomorrow.